So, metallic bonding. Different again to ionic and covalent. Not really so much about bonding. So we take an example, let's say sodium atom. So there's a sodium atom, it's in group 1, so it'll have 1 electron in its outer shell. Well, in a big lump of the metal, there'll be, well, literally billions of sodium atoms close to each other. I'll just have sort of 6. So this represents a small piece of sodium metal. Now, at the moment, there's nothing holding those atoms together, so they just separate. But what does happen is the outer shell electrons, so that's the only ones that I've drawn, leave the pull of the nucleus. Okay, they become sort of delocalized electrons. Okay, they free themselves from the pull of the sodium nucleus, and that electron does it for all the sodium atoms. So what you end up with is a sodium ion. Okay, so I have sort of 6 sodium ions, and they'll all be 1 plus charge because they've lost 1 electron. That goes back to electron configurations and to make ionic bonds. So they form sodium plus ions. The outside cell is sort of empty, and in between, in and around all those sodium ions, 1, 2, 3, 4, 5, and let's put 6, are the 6 electrons. Now those 6 electrons can move anywhere in and around. They're constantly in motion. Okay, in and around. One might be going that way, or it might go up that way. In and around the sodium ions. And this movement of electrons, the outer shell electrons, is what's known as a sea of delocalized electrons. Okay, it's not really a sea. Sea is water, but it's a sort of a fluid. It's something that's in motion. The electrons are always in motion, in and around, and it's those negative electrons basically will be attracted to the positive, and that one will be attracted that way, and the sodium will be attracted to the negative electron. So each of these sodiums is attracted, ions, is attracted to the electrons around it, and the electrons are attracted to the sodiums. Okay, there's just sort of example. So it's these electrons, the sea of electrons, sort of, you can think of it as sort of glue the sodium ions sort of together. Positive to negative, negative to positive, attractive force. Now, for sodium, that's 1 electron. For something like magnesium, because magnesium's in group 2, so it would have 2 valence electrons. So magnesium, when it forms ions, will form 2 plus ions. So there's magnesium, only going to draw 4, but each of them has lost 2 electrons. So in between these magnesiums, 2, 3, 4, 5, 6, 7, 8, are 8 electrons holding the magnesium nuclei together. There'll be attractive force going that way, and there'll be attractive force going that way. So again, sort of gluing everything together. Now, for magnesium, it's got more electrons. It's got 2 electrons for every magnesium atom, ion, whereas sodium only had 1. So magnesium has more, double really, more electrons delocalized, therefore has sort of higher conductivity, electrical conductivity, and things like higher melting point. All these things depend on how many electrons are in between. The magnesium's got more because it's in group 2, because it gives off 2 electrons than sodium.